You probably have heard of the term Internet of Things, or its abbreviation IoT. But what exactly is the Internet of Things? Well, do you ever think about what it would be like if all your things could communicate with each other? Your kitchen serves food to your pet when you're not around. Get a notification when there is a water leakage and make an appointment automatically on your available time with your plumber. Your home greets you with your favorite music when coming back home. Your car locates and parks automatically in an empty parking lot. Control all electronic devices in your home using only your smartphone or voice. With IoT, possibilities are endless. Now let's learn about Internet of Things and how to program it. This course is meant for BTI employees with an interest in Internet of Things. There are no prerequisites or prior experience regarding the subject matter needed. This course starts from the very basics and then slowly move up to the more advanced concepts. We will use very easy and interactive language Lua script to do programming, ESP8266 for development board for embedded device, and cloud-based services and solutions for IoT. This course contains projects using various sensors and actuators like LED module, motion sensor, DHT22 temperature and humidity sensor, digital push button, and etc. The course contains detailed projects using various clouds like ThinkSpeak and Cloud MQTT. It will explain the concept of MQTT and IFTTT services, as well as advanced concepts like HTTP to MQTT bridge using AWS and controlling things using voice commands in detail. In this lesson, we will have a brief introduction to Internet of Things and we will try to understand what the Internet of Things is. There are multiple definitions for Internet of Things. Let's go through a few of these definitions, and as we look through them, pay attention to the keywords marked in red. The Internet of Things is the extension of Internet connectivity into physical devices and everyday objects. Embedded with electronics, Internet connectivity, and other forms of hardware, these devices can communicate and interact with others over the Internet, and they can be remotely monitored and controlled. Internet of Things represent a general concept for the ability of network devices to sense and collect data from the world around us, and then share that data across the Internet where it can be processed and utilized for various purposes. Let's have a look at another definition. The Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. The Internet of Things is the interconnection of uniquely identifiable embedded computing devices within the existing Internet infrastructure. So the Internet of Things, or IoT all in all, is simply connecting embedded system to the Internet. From the definitions we went over, as you have noticed, there are some keywords that are repeated throughout. Sensors, actuators, network devices, Internet, embedded computing devices, and unique identifiers. Now let's go over each keywords. First, sensors. A sensor is something that is used to collect data from the environment. Any sensor such as motion sensor, temperature and humidity sensor, water flow sensor, proximity sensor can be used with IoT. An actuator is a mechanism for turning energy into motion. Actuators are things like relay, servo motor, display, LED, and so on. Next is embedded computing devices. These devices have the ability to read the data from sensors. They do things like read and interpret data from sensors and receive and send instruction to the actuators. Simply, if motion is detected, switch on the LED light. If the temperature is too high, set it to moderate or low, or what they do. Unique identifiers. Every IoT device has to have a unique ID to be callable and operable. Networks. IoT devices are tied together by networks using various wireless and wired technology standards and protocols to provide connectivity. MQTT, WebSocket, Node, Wi-Fi, Bluetooth, and others can be used with IoT. Not all devices may need to be connected to the Internet independently. Rather, a cluster of devices could be created and the base station, or the cluster head, could be connected to the Internet. For example, if you have multiple temperature sensors in different rooms in your house, it is not required to connect these sensors individually to the Internet. All these sensors could be connected to a single device sharing temperature values. Then, there are platforms and services available for the Internet of Things to make everything easier, faster, and more convenient. Going forward, we'll talk in more detail about these components and applications. Now let's look at how sensor to actuator flow works with an example. Let's assume you have a smart home setup with a smart sprinkler. When you're away from home, your neighbor tosses a cigarette butt to your yard and causes a fire. Your temperature sensor detects heat and sends the detect signal to the control center. Control center then sends the command to sprinkler to turn on. The sprinkler, an actuator, then turns on and puts out the flame. The whole sensor to actuator flow is simply sensor detecting and sending the detect signal to the control center sending appropriate command for the detected signal to the actuator, then actuator performing the received command. Next, let's talk about the embedded IoT platform. There are various boards available to work on the embedded IoT platform. Raspberry Pi is the most well known. Then there is Arduino, Linkit, BeagleBone, Intel Galileo, and there is ESP8266. There are many boards available in the market which you can use for the development. In our case though, we will be using ESP8266 for our lessons. Embedded systems provide easy access to IoT programming. They're relatively cheap and affordable, they're tiny and do not take up much space, they do not consume a lot of power, and most importantly, they're very easy to use and learn for beginners to program with. There are diverse programming language options for IoT development. Python, Java, JavaScript, C, Lua, and many more languages can be used depending on what kind of IoT device you're building and what kind of requirements you have for it. In this tutorial, we will mostly use Lua script. Lua is very similar to JavaScript and it is very easy to use. In the future, we will try to add more tutorials using other languages as well. The component of IoT that is gradually becoming more integral is the cloud-based IoT services and solutions. Cloud-based IoT services enable users to store files and applications on remote servers and then access all the data with the internet. There are various cloud-based services and solutions for IoT like IBM Watson, AWS IoT, IFTTT, ThingSpeak, Cloud MQTT, and more. Thank you for watching the first lesson of the course. In the next lesson, we will talk about Lua language so that we can jump into the IoT programming.